As I said before, my name is Nikita. And a little bit about me. I have 2 years on Frontend Developer, and I have one more year as a teacher, and more than 2 years of non-commercial development. So, what you will learn during this presentation? The first thing is the basic concepts of functional programming. The second one is a little bit about Haskell. What you will see during this presentation. The first thing is how I came to this topic of the presentation. The second one is the rules of the functional world. The third one is a few examples in JavaScript and Haskell. And some small performance overview. So guys, I have a question for you. Who's seen the Avatar Legend of Aang? Can you heads up? Oh, a lot of people. Do you remember this guy? Yeah. He was famous fairy magician who was creating new type of magic. He was light magic, and he is creating by just observing water magician and try to reproduce his technique. And today we will do approximately the same thing. We take Haskell and try to repeat his practice on JavaScript. Let's start in the beginning. What is functional programming? The functional programming is about the pure function. Functions are first class and high order. Variables are immutable, and relative transparency of function. If you don't understand some point here, don't be scary. I will clarify every point here. Functions are pure. What it means? Actually, in the simple world, it means your function don't reproduce any kind of side effects. It's easier to show you on some example. Well, what not to do. Here we have simple function which increases our variable, but it's doing by using out of scope variable, and it provides some kind of side effect. How do you do it in a functional way? Actually, it's the simple one. You just provide some kind of argument and increase this value inside of scope this function. Functions are first class. What does it mean? Do you have any ideas? Seems no. Well, actually it means you can provide your functions as an argument to another function, or you can return your function by another function and can assign as a value to a variable. Higher order function. Actually, it means pretty the same, but not really. Actually, you can take your function from like an argument to another function, or return your function from a function. You will be heard a lot of function world today. Variables are immutable. Actually, it's pretty simple. It means you can't use any var, let, or something like this. You can use only constants. Relative transparency of function. What does it mean? Actually, it means you can change your function by just a value. Like here we have example. We have function which calculate two numbers, and we can get this number by just call this function or just provide this number. So let's start with a simple example. What do you think a function that sums all numbers up to n would look like? Here I need to clarify a bit. In the functional world, you can't use any kind of loops. No for, no while. If you need some loops, you need to use recursion. So after this information, our function will be looks like this. Here we have some function which get one argument, and by recursion we just calculate our sum. Actually, it will be pretty the same in Haskell, but here we don't have any kind of ternary operator, and we need to use some if-then construction. but the rest of function will be the same. Guys who started looking into functional programming look like this. But it's not really. Well, actually, I would like to discuss a bit my experience of using Haskell. In Haskell, you have two parts of your application, purely functional part and just functional part. In a purely functional part, you can't use any non-purely functional data structure like array, or you can't provide some side effects like user input output. But on the just functional part, you can't use normal data structure, and you can provide some side effects like user input output. So what are purely functional data structure? As I said before, it's can be mutable data structure. So in JavaScript, we have some const, but we can provide like a const, our array, but it's still mutable because we can push or shift our data from this array. So purely functional data structure are persistence. Purely functional data structure are often represented differently than their imperative analogs. And well, as I said before, arrays can be replaced by a random access map or a list, which allows for a purely functional implementation, but the access and updates times will be logarithmic. So, shall we imagine some world without arrays as a part of our presentation? What are gonna need for this? Well, actually, the first thing which we need is think about which data structure will be closer to our array. Well, in my opinion, it was some object, and we need to somehow to create this object. Let's create this function. It will be look like this, and it's take two arguments, the first element and the second one. First one will be always some kind of data like a number, string, or doesn't matter what it was. But the second one, it's always will be another pair. Like you need to think about this data structure like about Russian matryoshka. Like you can open your matryoshka and find another matryoshka or find nothing. And if you find nothing, it means your Russian matryoshka is the end. So what operators do we perform on arrays? The first operators which I can think, it is some access operators. So let's create. Here we have two functions, FST and SND, which takes the first element and the second one. Like here, we will get number 11. And here we get number 10. Because I take this idea from the Haskell, let's take a look how it will be look in a Haskell. Well, actually it's already implemented and it works the same. You can call FST function and get 11 and the same about SND. So let's take a bit bigger example. Here we have arrays on 3 elements and the last one will be null. It's needed to understanding for our array is a finish. But in the console, it will look a bit ugly. And let's create some kind of bridge between our purely functional data structure and the normal one. Here we have function list to array, which getting our purely functional array. And until he's getting null, he's just push data to our array and return it. And after we apply our list to array function to our array, we will get the normal one. So, and to be fair, let's create the inverse function, which will be transform the normal array to purely functional array. Here we have the same story. We just create a new pair until we don't finish our array. Any other ideas what our array is missing?
Split or?
No, in my opinion, it was the most using in my work method of array. It was map. Well, here we have function which getting two arguments. Like first one, it will be function which will be applied to our elements, and the second one it will be our array. Here we're using recursion, and here we create new kind of pair, apply our function to first element, and call our map by using recursion with the rest of our array. Some example of using. Here we have list array function to be more readable, and we just apply some sort function and create new range. It's like our kind of array, but from one number to the second number. And it works great. How about a little performance test of what we are writing? Here we're creating a new array and do some kind of calculation of this number array. And here we have the same story, but for our purely functional array. And that's results. Here we can see functional programming a bit loose, but I need a bit clarify here. JavaScript, it's not purely functional language, and he has some restrictions of using recursion, like a type restriction, and he has some performance issues with using recursion. So what's his pros and cons using functional programming? Well, actually, in my opinion, it's easy to test your functional part of code because you don't need to prepare your part of code to do some testing, because all your function will be pure. The second point here, it's easy to develop, but on the same way, it's harder to start it because you need to know a lot of stuff. And one more cons, it is not really applicable to every kind of task. So let's summary a bit. We take a look how our array will look like on purely functional style, and we concluded that most of the things the language doesn't not provide you with can always be realized by yourself. That's pretty much it for me, but there are a couple of bonuses for you guys. The first one, it is in Haskell, you can create the normal function. Your function will be always carrying. And the second one, it is in Haskell, you can create some kind of template function. What is current function? Current function, it is function which you which return your new function from the previous one. It's it can be applicable like particle applying, like here. It can be applying or on some function composition and maybe some error handling. Well, actually, to do not it every time by your hand, you can create some kind of after carry function, which will be after carry. But it is my implementation, and if you don't want to write it every time on every project, you can just install some kind of functional library like Lodash, which provides the same stuff. And let's apply it. Let's try it. Here we have function which getting 4 arguments, and we apply our carry function, and after that we can call it by this way. And As I said before, in Haskell it's already implemented. Here we have the same story. Here the sum function, which takes 2 arguments, and we can call it by using 2 arguments or apply it to another function and call it with 1 argument. What about template functions? In a Haskell, you can create a template. There is template for the main function, and these templates will be called before you start deep into the main function. Like here, you will see, like, if you have 3 arguments and the third one will be 0, your function will be always return 0. The same story for number 1, but here we will return number 1. The same story for number 2. And here, if we are getting number 3 like a third element, argument, then we calculate 2 arguments between them. And only after these templates, we started deep into the main function. Thank you, guys. Do you have any question?